The last topic of discussion is analyzing simple harmonic motion. I only have one vocab term for this section, and it is frequency. Frequency describes the number of complete cycles for each unit of time. It is found by doing omega over 2 pi. If you notice, this is just the reciprocal of the period. So F is equal to the reciprocal of the period. So let's do an example where we find multiple things. We're going to be finding number 1, maximum displacement, number 2, frequency, and number 3, the time it requires for an object to complete one cycle in simple harmonic motion. For our final example, example 4. A mass is attached to a spring on a smooth surface. It moves in simple harmonic motion described by D equals 10 cosine pi over 6 t, where time is in seconds and D is in centimeters. We're going to find A first, the maximum displacement. So I'm going to draw a little picture of what this actually looks like. Let's move this down. So what's happening here? I have some kind of object on a smooth surface on a spring. This is my resting position. And it can be pulled out to the right and then released where it makes this back and forth motion, or it can be pushed in and released and have again back and forth motion. Since it's positive 10, I'm going to assume that we're pulling it out this way and releasing it, because this direction is positive and this direction is negative. So let's decide what is the max displacement. Well, before in the definitions, we said the max displacement is the amplitude. So here's my A value. This must mean that the max displacement is the absolute value of 10, which is 10. And it's not just 10, but what are the units? Centimeters. Next, we want to find the frequency. So before we defined it, frequency, where did I define it? Right here. Omega over 2 pi. So frequency F equals omega over 2 pi. So our frequency here, omega, is pi over 6 over 2 pi. I do copy, change from divide to multiply, and flip. So this is like 2 pi over 1, so if I flip it, it's going to be 1 over 2 pi. The pi's cancel, and I'm left with 1 on top. 6 times 2 is 12. So how do I write this in terms of the problem? It takes 1/12 of a cycle to complete 1 second. Next, C. What is the time required for a full cycle? Not to get confused with the frequency, which tells us that for 1 unit of time, which is seconds, so we're looking at only 1 second. This is how far it's gone. Now we want to know for 1 full cycle, not for the time. So let's check. Before we said that the frequency is the reciprocal of the period. So that means I can either use this to find the time for a full cycle, or I can just use the formula for period, which is 2 pi over omega. So let's try it and then compare it to the reciprocal of 1/12. So 2 pi over 6, copy, change, and flip. The pi's cancel. 2 times 6 is 12. So it takes 12 seconds to complete 1 full cycle, which is exactly the reciprocal of this guy here. You're going to complete the next problem on your own. Then, in your book, you're going to do your assignment. If you don't have time to finish today, you're going to do it for homework. It is 26 problems. Ooh, I don't have the page number. You're going to do 2 through 12 even, which is 6 problems. You're going to do 13 through 16 all, which is 4 problems. You're going to do 17 through 20 all, which is also 4 problems. You're going to do 22 through 28 even. which is 4 problems. You're going to do 51 through 54 all, which is 4 problems. And you're going to do 59 through 62 all, which is 4 problems. It's in your book under section 4.8. You just need to find that section. If you want some extra credit points, you can do number 30, 32, and 34. I will be back tomorrow, so if you have any questions, I'll be here. I'll also be here today after school in room B, 20, what is that room number? I think it's 202. So get to work.